So here is our composition book, and we are going to be working on the foldable that we're supposed to create. All right, of course, we're going to be turning this composition book upside down like that, right? Because we have a couple of words to go over. All right, so here are the ticks. First of all, this is 8.5. Letter A, describe the structure and the parts of the atom, right, including its mass, electrical charge, and the location of particles. All right, so the first one is the atom. As you can see, if we flip, the says that the atom is the smallest unit of matter, right? Also is the building blocks of all matter. Please report to the office. Kayla Gonzalez, please report to the office. Just keep in mind that the video is going to go fast, so you can pause the video so you can write the information down. The nucleus of the atom is the center of the atom, and inside the nucleus, there's a couple of things that you got to keep in mind and write down. All right, so this is the center of the atom. It contains two types of particles, protons and neutrons, as you can see. All right, the mass is found here because all you got to do is count all the protons and neutrons, add them up together, and that will give you the mass of the atom. The charge of the nucleus of the atom is positive because you find protons in there, and therefore only positive particles are inside, so it gives them a positive charge. Moving down to the energy levels. On the energy levels, we have they are found around the nucleus. Those are the little circles going around on the outside. The electrons have a negative charge and are found outside. Obviously, the electrons are found here. The electrons are embedded on those energy levels. And this is an example of all three energy levels and how many electrons each energy level has. This is the first energy level. It has 2 electrons. The second energy level can have up to 8 or less, but no more than 8. And the third energy level also has up to 8 electrons. No more than 8, once again. Make sure you copy this down. Let's move on down to the next one. This is the Electron Cloud. The Electron Cloud is just a different model that we are going to be using. It has different components on it. This one, you can write down that it surrounds the nucleus, outside the nucleus, right? It contains also electrons, but this one's in a very unpredictable location. It's hard to tell where the electrons are located at any given time. All right, moving down to the next one. This is page 77. On page 77, you're going to have protons, neutrons, electrons, and valence electrons. Right, so starting with protons, these are the ones that are positive in charge. These are the positive particles. All right. They are located inside the nucleus of the atom, and they actually have a weight, a relative weight. The weight is 1 AMU. Remember, these particles are super small, so it's just impractical to use numbers in terms of grams or anything else. So we're just gonna give them this 1 AMU, atomic mass unit, right? That is the weight of that. Well, let's go over the neutrons, because the neutrons are also located inside the nucleus of the atom. These particles have no charge, or we can put 0 charge. They are located, once again, in the nucleus, and their weight is also 1 AMU. They weigh as much as the protons. 1 AMU is 1 atomic mass unit. Now let's go and look at those electrons, the ones that are revolving around the nucleus of the atom. These are the smallest particles. These are very small compared to protons and neutrons. These ones are a tiny fraction of it, all right? They are negative in charge. They are located at the energy levels or in the electron cloud. Remember, we have 2 models that we're going to be working with. The weight on this one, we can say that it's 0. It doesn't have any weight or any mass. They do have some mass, but they're so tiny that we don't even consider it, right? Because they're very small. On the other hand, we have valence electrons, and valence electrons are electrons that are located on the outside. These are electrons that are located on the outer energy level, whatever last energy level the atom has, and whatever amount of electrons they have on that energy level, that those can be considered the number of valence electrons. The valence electrons are very important because they determine the reactivity of an atom. It all depends how many valence electrons they have. That's how reactive the atom can be. All right, let's skip to another page, or the last page, which is page 78, and we have two more over here. We got the atomic number. The atomic number, it represents the number of protons in the nucleus of the atom. All right, so keep that in mind. That number is very important. We're going to use it a lot. It identifies the atom element, or yeah, you can easily identify elephant. What? You can identify which element an atom is just by looking at the atomic number. So this is why it's very important. It's equal to the number of electrons, and the number of protons is supposed to be equal to the number of electrons also. So for example, if an atom has 10 protons, it should have 10 electrons also if it's balanced. That's why P is equals to E, or protons equals to electrons. The atomic mass. Now the atomic mass is found inside the nucleus of the atom. And we find the atomic mass by adding. We're supposed to add all the particles inside the nucleus. All right, like for example, we add the protons and the neutrons. Those are the two particles inside the nucleus. And that's how you find the mass of the atom. All right, so we're done with those. Now let's move on to the last one. The last one is on page 79. This is the two models that we're going to be using, where this one is called the Bohr model, and this one is the Electron Cloud model. And here you got A, B, C, D, and E, where this is the nucleus of the atom. You can see letter A. This will be an energy level. Actually, we have two energy levels. Remember I told you there's two electrons on the first energy level? Well, there they are. This one's over here, letter C, is the protons. These are the positive signs. The neutrons have no charge, and then the electrons have a negative charge. I'm going to zoom in to see if you can see that small one, right? They're very tiny. All right, going to the electron cloud model, it's pretty much going to be similar, where the electron clouds are outside of the nucleus. This is letter A. This is the electron cloud. All right, on the B, you have your nucleus of the atom, and then letter C will be your electron. As you can see, this very tiny one. Letter D is pointing at this positive charge particle, which is the proton, and then letter E is pointing to the neutron, the one that doesn't have any charge. Remember, neutrons don't have any charge. And that's pretty much what we put inside this foldable, right? Model 1 is the Bohr model. And you got your A, B, C, D, and E. Likewise over here on the electron cloud model. You got your A, B, C, D, and E. Make sure you write all that information. Pause it at any time. And that will be me on Saturday, because I'm going to go fishing for sharks. Yay. All right, guys, this is the whole thing that we have for today. Make sure you put this, have everything ready for tomorrow. Bye-bye.